of the secant inverse of x dx is equal to what? Oh, there it was right there, by the way. Show basically that's equal to 1 over x times the square root of x squared minus 1. Again, we do the same thing. We're going to call this y. So it becomes y is equal to the secant inverse of x. We do the same thing, just like what we did here. Since this is the secant function, or the secant inverse function, we take the secant of both sides, of the left side and the right side. You end up with the secant of y is equal to secant and the secant inverse cancels. You end up with x. And we do the same thing again. We take the derivative with respect to x. And you end up with the derivative of secant is secant of x, y, times the tangent of y times dy dx. And on the right side, the derivative with respect to x of x is going to be just 1. We're trying to solve for dy dx at this stage, because that's what we're looking for, the derivative of that. That's going to equal 1 over the secant of y times 1 over the tangent of y. So far, now we're going to change this around. This is a reciprocal function of the cosine of y. That's the reciprocal function for the cotangent of y. So dy over dx is equal to the cosine of that angle. Oh, we didn't do the triangle at this stage. We should have done it here. Excuse me, I should have wrote this down. Secant is of that angle y is equal to, secant is the cosine, so it's adjacent over hypotenuse over adjacent, x over 1. This is going to be the square root of x squared minus 1. If you use the Pythagorean theorem, I think you can see that. Good. The cosine of that angle now is equal to adjacent of hypotenuse, 1 over x, times the cotangent of that angle, y. Tangent is opposite over adjacent. Cotangent is the reciprocal, adjacent over opposite. 1 over square root of x squared minus 1. And we simplify that to 1 over x times the square root of x squared minus 1. Some books like to put an absolute value depending on the book, but most books will not have the absolute value. So did we do it correctly? Show that that's equal to 1 over x times the square root of x squared minus 1. Good. QED, quadratus demonstrator, and thus I have demonstrated. Box it up, and we're done. The last question that we're going to be doing is problem number 7. The derivative with respect to x of the sine inverse of x over a. Show that that's equal to square root of 1 over the square root of a squared plus, minus x squared. Note that this a is a constant. It's not a variable, it's just a number. A can be 4, A can be 7. We don't know what that is, but we're just going to call it A. Okay. So we do the same thing. Call this y. Y is equal to the sine inverse of x over a. We take the sine of both sides. By now you should know that it will become sine of y and get x over a. This is the same thing as 1 over a times x. It's a constant times x. Some students still have a problem with this. Make it come out this way. It's the same form, either or. Now we do this. We take the derivative of this. The derivative of the sine of that angle is equal to the cosine of y times dy dx, which is equal to at this stage, you could have done it this way. I'm going to go a different route on this. Sorry about that. I'm going to go a little bit different route on this one. We know that when you take the derivative with respect to x of this function, so since I already proved it out, I'm going to use the formula that we're given. dy over dx is equal to, it's a little bit easier, per se, maybe. The derivative of sine inverse is 1 over square root of 1 minus x over a, quantity squared, because that's our variable, times the derivative with respect to x of x over a. That's the chain portion. We have to take the derivative of that. That becomes, if you're not familiar with this, just write this as 1 over a times x. This is a constant times a function. The derivative of the constant times a function becomes 1 over a. So dy over dx becomes 1 over a times 1 minus x squared over a squared. So this part is going to get a little bit hairy. That becomes a squared over a squared minus x squared over a squared on the inside of that. Because I want to, these are partial fractions, I want to get into a single fraction. That becomes square root of a squared minus x squared over a squared. That becomes square root of a squared minus x squared all over square root of a squared. That becomes just a. So let's rewrite it neatly here. dy over dx is equal to 1 over a times the square root of a squared minus x squared. There's that portion divided by a. These cancel, and you end up with 1 over square root of a squared minus x squared. I could have done it this way too as well, but I decided to take another route. You get the same answer, or you should. QED. Note that if you have the integral of 1 over, so here's an example, square root of 16 minus x squared dx, we should be able to take the integral of this. It's going to be sine, where our a value is equal to 4, correct? Because that's 16. It's going to be sine inverse of x over 4. Since it's indefinite integral, we should have to add a constant to that. Hope it helped. Please study hard, work hard, play hard, enjoy life.